So, good morning, children. So, the topic for today is differential protection of generator. So, now what is differential protection? This is also the first topic from the unit 2, generator, transformer, and busbar protection. Yesterday, we covered the interturn fault protection. This is the differential protection in order to protect the stator winding, right? So you guys have covered the topic. What is differential relay? What is differential protection? You have seen that. Now we have to see that how does the differential protection work for stator winding of a generator, fine? So we'll move towards how it works. See, this is the line. This is the neutral, and here it is a terminal connected to bus bar. Fine. So here we'll connect the CT. Primary of the CT is connected to the line, and these secondaries are connected to the relay. So here this is differential relay operating coil. Right? So this is the line, and this is the neutral point, this is the terminal point connected to the bus bar. CT is placed on the either side of the lines, and primary is connected to the line. Secondary is having the differential relay operating coil in between. Right? So now look how does it work. See here. During normal operating condition, what happens? Here the line will be drawing some value of current, isn't it? So the flow of current will be in this direction. Fine. Now what happens? In the primary, the direction is like this. Due to the Lenz's law, in the secondary, the current will be induced in the opposite direction. So now the current in the secondary will be opposite to the primary. Again, this direction will be like this. Look, right? Then at the terminal, the bus bar connection or feeder connection, whatever will be there, it will be drawing the current, isn't it? So during normal operation, the flow of current will be in this direction in the primary of the CT. But due to Lenz's law, the secondary of the CT, the flow of current will be in opposite direction. Right? So this will be the mark of the flow of the current. So now this will be the direction of the current. Look. Fine. So let this current be I1 and I2. At this point, if we'll apply KCL at operating coil point, then I'll get it as if ID is any current of overcurrent relay, then it will be equals to I1 plus I2, which is equals to 0. Since it is balanced with balanced current on the either side of the CTs. Okay? So during normal condition, what happens? The current in the primary side will be equals to the current in the secondary side, and at that time the differential relay operating coil current ID won't be experience any value of current. That means this I1 and this I2 both are same. Fine? Is this clear? This is equals to 0 since I1 equals to I2. Okay? Now, suppose there is any internal fault. In this relay, suppose there is any internal fault. In that case, look how does it work. This is the case when there is any fault is not present. and the relay is successfully operating under healthy condition. But if there is any internal fault, then again there is the terminal point. CT arrangement is there. Look, CT arrangement is there, and this is the differential relay operating coil. Now, if there is any fault, say here, any fault in the internal zone, then what happens? There will be fault IF, fault current IF. Then from here, the fault current IF1 will be drawn. IF1 will be drawn, and since the fault is within the zone, again from here also, the direction of the current will be changed, since it will be drawing the current towards the faulty section, isn't it? When there is any fault, that means that will be drawing current from the other side, isn't it? So, say IF1 is the current drawn from the neutral end, and from the terminal end, the current drawn is IF2. Fine. So now, again, the direction of the secondary current, according to Lenz's law, it will be same. This, let it be small IF1, and again this is IF2. Now, previously, the direction of the current was same. At that time, this direction was also same. But now, the direction is opposite to each other. At that time, here, since IF1 is passing towards the faulty section, then according to Lenz's law, the secondary current will be in the opposite direction. And here again, towards the faulty section, the current IF2 is going, and so the small IF2 or the secondary current, according to Lenz's law, will be moving in the counterclockwise direction. Got this? Fine. Now, here, what happens now? See this. This is the direction. This is small IF2. Again, this is small IF1. Applying KCL at the point. Now, what you will get? ID equals to IF1 plus IF2. Both will be added on. Now, this value is a non-zero component. Again, over here, there will be some amount of current, because here IF1 won't be equals to IF2. Fine. So whatever value of current will be there, that will be flowing through this differential relay operating coil. Got this? Okay? So it will be experiencing some amount of fault current which will be drawn by this relay. Now, here, if ID sensed is greater than ID setting, ID is the operating current for the relay. ID is the deflecting current actually. Okay, that is the current which tend to operate the relay. If ID sensed is greater than ID setting, there is setting value in each and every relay. You guys have seen in the previous classes, right? So if the sensed ID is greater than the setting ID, the relays tend to operate. The relay will operate, or else it will restrain the value. Fine? Clear? Is this clear? So in a healthy condition, what happens? Both the CTs will be holding the same amount of current, due to which the direction will also be same towards the terminal to the feeder, isn't it? So at that time, the direction of the internal current in the secondary will be same, and in that case there won't be any operation, since there is no any value of current which will be drawn through the operating coil of the relay. But as soon as any fault, internal fault condition arises, what happens? This During the internal fault condition, the faulty current will be drawn from the other sides and that particular amount will be transferred to the operating coil of the differential relay. And if that sensed value is greater than the relay setting value, the relay will be under the operation. Fine? It's clear? Now, moving towards the next section. If there is any external fault, then this differential relay won't operate. How does that happen? You should say. If any external fault occurs, this differential relay won't operate. So how and why? See, suppose this fault is not present. Right? There is one external fault here. External fault, IF. Fine. In that case, look. In that case, this current, the current will be like this through the CT, and it will again take the current from the feeder. Means in the faulty section, the current will be flown from both the sides, both the ends. So, since a single current is covered by both the CTs, what happens? Again, the healthy section line criteria will be followed over here. Getting the first one which we have right now discussed, that is the healthy section. Since both the CTs will be having the same amount of current. The zone of protection is beyond the CT range, or it's beyond the relay arrangement setted area. So in that case, what happens? Whatever fault current is drawn by the faulty section, that will be from the either sides. So the one side, it will be covering both the CTs. In that case, both the CTs will be experiencing the same amount of current. So in that case, same amount of current at both the ends. Primary is having same current. That means secondary will also be having same current. That means the condition that we discussed firstly will be followed. Got this? Is this clear? Fine. So now here again, ID equals to IF1 plus IF2, which is equals to 0. And that means if it's 0, then this operating coil won't be operating for the differential relay. Actually, differential relay में जो है, it will be operating only if the differential amount of current value persists. If the differential value of both the CTs doesn't persist, then it won't operate. Got this? Fine. Now, for heavy external fault, say the severity of fault is not much, then this is the condition what I discussed right now. But if the external fault is very heavy, then what happens? This relay will operate. If any external fault occurs and if it is heavy, then the relay will operate. How and why? This is due to three reasons. That is CT's phase angle error. Firstly, CT phase angle error. Both the CTs will not be matching the phase angle with each other. So there will be some error due to which the relay will operate for heavy external fault. Second is the CT ratio error. CT magnitude ratio. In that also, the CT will tend to make the relay operate. Third is the CT saturation. Now what is CT saturation? CT saturation means due to heavy external fault, CT saturates down and one current vanish of CT, which is the secondary current of the CT which saturates. Okay, the CT will saturate, its secondary current will be vanished off, due to which there will be the difference in the value of currents in the CT, due to which again it will tend to operate the relay. So for nominal external fault, the system won't operate, but for heavy external fault or extreme external fault, intense external fault, this relay will tend to operate, or this arrangement will tend to operate. Fine, clear? Now, which is not satisfactory? I must say the operation of this arrangement for even heavy external fault is not satisfactory. It should not operate for external fault. So there is where we'll introduce merged price circulating current scheme or percentage differential protection scheme. Okay, understand that this arrangement is good enough for internal fault and light external fault. But if any heavy external fault occurs beyond the zone, it shouldn't operate. But this arrangement won't withstand the heavy external fault. It will operate within the zone. So the people at the handling end, they won't be able to understand that whether actually the fault has been occurred. If relay has tripped, that means some fault has been experienced by the relay. So beyond this limit, it should not sense the fault. Okay? So for overcoming this problem with this circuitry, we introduce percentage differential protection or merged price circulating current scheme or biased protection. Fine. So in that arrangement, I think the board is not clear for you guys. Okay. So I'll tell you, I'll make sure that the diagram is clear in the next class. So for that, I'll verbally tell you what we'll do. Now, for that, what we'll do, we'll set an additional restraining coil over here. What we'll do, it's a line to be protected, and CT arrangement is like that, same only. But here, in the secondary side, we'll introduce a restraining coil for the CT. So what that restraining coil does, restraining coil will restrain or which will counterbalance the action of the deflecting coil, by providing the deflecting restraining torque. Fine. If unwanted deflection is there, then that will counterbalance by providing the restraining torque. Got this? Now, how to know that how much restraining torque is needed? Getting the question? There will be a question that how will get that, how much restraining torque is needed? That will be controlled by the number of turns of the restraining coil. So depending upon the turns of the coil, you will restrict the restraining torque of the system. Fine? Clear? So, in merged price circulating current scheme or biased differential relay, you will introduce an additional restraining coil in order to restrict the working of relay for heavy external fault. During the normal operation, during the inside fault, internal fault and light external fault, this operation, this system is good enough. But if any heavy external fault has been experienced by the circuit, then this arrangement should not get tripped. So in order to restrict it from tripping for heavy external faulty conditions, we'll use the merged price or percentage differential relay scheme. The percentage differential relay scheme will introduce an additional restraining coil in the secondary of the CT. And how to know that